a vector of mutable reference to entity. So location.x. Actually want to take you. Replace this assert equal, and we just want to assign this to something like that. Right, your entity to get 1. All right, so now you're just yelling at me that we don't have this method here. Let's go create that. All right, so we're gonna have a mutable reference to entity as our return value, which means let's mutable entities, make this a vector. We need to make this mutable so we can push into it, and then we're going to return mutable entities. All right, so now it knows what type it is too. So next up, we need to loop through and find the. Well, is that true? Not really, because if I need to get just all of the entities, I don't need to look at the grid part that has the IDs at all. I just need to go straight to the entities and just say like, hey, just give me everything that's mutable. And so we can iterate through that and then push these in as we get them out. I think that works. So we can do self dot entities. What do we have in here? It's like, I don't think we want. Yeah, see, drain clears the map. I don't want to remove it. I don't want to remove anything or retain. Okay, so there is values, values mute, which gives me all the values. It's an iterator visiting all values mutably in arbitrary order. Perfect. So we can do values mute, and since this is an iterator, we can do this as a for loop, or I can do this as a for each. I don't know if it really matters that much. So in here we're going to get an entity, and we're going to mutable entities dot push entity like that. So it's a one-liner that then just pushes a mutable reference into here, and then we return it. So actually a little bit easier than our previous grid. So if I run this test, it passes. Excellent. Okay, so that's easy. Get all cloned. So this is a light clone because we've implemented clone that doesn't clone some of the, more interesting things like the, the dynamically dispatched stuff. So let's go ahead and implement that. So CI test get all cloned entities from grid. We do need to make this mutable so I can get them. So mute grid new. Actually, you know what? For the setup we could just do this exact same thing. I don't know if I care about the IDs in this case. Like, we've already tested that we can get these things out. I do think that for one of these, though, or maybe both of them, because it's arbitrary order that they're coming out at. So we have these create entity. Let's set the physics system to be a box new. I think we only have a player physics system. That's a player draw system. Player physics system default. Okay, so that should make that happy. I want to do this to both of them. That way they both have physics systems, so that way when I get them out, I can just test one of them to see if like the physics system is a none. We need to insert these in. Grid.insert. Get one. Okay, so we've inserted both of those. Then I need to get them all. Okay, so what type are you going to be? You're going to be a vec of entity. So it's going to be a full owned entity. I don't have to pass in anything. And there we go. So that's what we should get. Then we should be able to assert we want to assert matches that the, okay, so I guess like two things, right? So assert equal the cloned entities dot length. That is 2. We also want to assert that matches for cloned entities position 0 dot physics system that you are a none, because it's an option. And when we clone, we get a light clone, which means we don't get the physics systems, we don't get the draw systems. And so this should be a good test to see like, hey, you know, do we have like, we have a clone, but it should not be like a full clone. All right. So if I save that, get all clone doesn't exist. Let's go implement it. I don't need to mutate anything, so I can just have a reference to self, but we're going to return a vector of entity. Okay, so if we set all that up, I think that we're going to be able to do something very similar to this one. We're going to be able to do self.entities. We can go through all the values. We can just do a for each for these. We're going to get an entity, which is just a reference to an entity. And then we can cloned entities.push entity.clone. And that's it. You need to be mutable. And I think that should make this test pass. Ah, it does. Okay. What's next? Move entity. Okay, so every time that the entity moves, we want to ensure that they're in the correct grid location. So what is that going to look like? So CI test, move entity between cells. In grid. Okay, so same thing here. Create a grid, create an entity builder. I think in this case, all we have to do is one entity. So we can just have a single entity. It doesn't really matter that we have a physics system or not. But we are going to want to pay attention to our location, like which grid cell that we're in. Hello, Zilby again. Oh, more pair programming. I don't know if you can tell, he's tired. Like, he wants to play, but he's also really tired. Alright, what did you do? Oh, did you not do anything? Oh, you just searched for stuff. Oh, that's perfect. Okay. To explain, to show why I may be a little bit slower right this second. Okay, so we have our location, a question mark. Okay, move. Okay, so we created our location. Let's do this at, if we put every 2 is a cell. That's our unit width. So if we do something like just a normal 1.5 and a 1.5, then we know that we're gonna be in 0 through 2, so we're gonna be in 0, 0 is our index. So we're gonna insert this entity into the grid. Okay, so then after we insert into the grid, I want to get the entity. We want to get that entity. Now we have this. We can get all entities mutable. So that works for us. We know there's only one. So we can do let entities okay, so this is gonna be grid dot get all entities mutable. Okay, so now we have all the mutable entities. I want to mutate one of the entities. And we know that they're already going into the correct the correct cell in here. So I don't need to test that ability again. We're testing the move now. So now it's going to be moving. So we want to say entities of position 0 dot location. Let's set our X. Let's move this entity to the right by 1 cell, let's say. So that means 2.5. So equals 2.5. Then I want to tell the grid to update. Now there's a couple ways we can do this, because I'm not sure the best way to do this. I could hold, I mean, I could just run update on the grid, like have an update method, and it has to recalculate all of the entities to make sure they're in the correct index still, or like the correct cell location. Or we can call update for each entity and then just one off do that. I'm not sure there is a really better way. I guess there is a third way. We could internally in state store the previous tick's locations for the entities. Maybe even do a light clone, because it's not really much of them. And then that would allow us to... Yeah, I don't know if I like that as much. Let's go with our original idea of, we're going to call this with the... Oh, we can call it with the ID of the entity that was moved. So we can now say grid dot check move. That doesn't feel like it's gonna... Okay, move entity and pass in entities position 0 dot ID. Okay, so that's one function we have to add in. Given that okay, so we move the entity, and then we're now going to assert that the cell that we're in is correct. So the index that we're in is now going to be 110, I believe. So assert equal grid.cells. This is a hash map. So dot get. The key is going to be a reference to, let's see, I think it's 1 0. And then I want to unwrap this. And then we're going to want to get the length. And you should be equal to 1. You should have 1 in you. Okay, so move entity. Take immutable self. And we are passing in the ID, right? Yes, we're passing in the ID. So what does that look like to us? That's the entity ID, which is a U32. We're not going to return anything. We're just going to move it if necessary. We're calling this after the entity has been moved. So I don't think I need to pass in. I don't think I need to do anything. Well, actually, here's a much better question. I might build. Maybe I can do this, like, in a better way. Maybe there's a fourth way of us handling this. What if I had an update function and update just ran update for all of the entities? And then it could handle the move here. Oh, I think I like that a lot more. That's gonna make it a little bit harder to... It's gonna make it a little bit harder to do the test, though. Is that true? If I create my own, let's say I create a hub function update. And we're just taking in whatever is necessary to update all these entities. So I'm not really sure off the top of my head right now. I don't think we need to return anything. And then we would loop through all the entities. That would be self.entities dot values mute. Okay, we would be able to for each the entity, and then entity dot update. Okay, so we need gravity and the collidable others. Well, we can get the collidable others here. So if we do this, update doesn't return anything. Well, it returns a Boolean, but I don't actually need that here. Because if I multi-line this, we could say something like let location, so old location equals entity dot location. Then we can update the entity. So entity dot update, gravity and collidable others. So all we need coming in here is the gravity. So gravity is, I think that means a vector 2. F32. Collidable others, we just need to get a list of all of these other vectors that have like the collidable bit on them. Then let new location equals entity dot location. We need to test to see if they're the same. So if old location is equal to new location, I just brought in new, didn't I? Yeah, don't want that. Okay, so if old location is the same as new location, then, and that's the thing is, if they're not the same as new location, that's when I want to determine if we should move this move the entity. So then that's where we would do self dot move entity and pass in the ID. So that would be the entity dot ID. But we might be able to do one better because we already have the old location and new location. I might be able to pass in the old location and new location too just at the same time right here. So we have the entity ID, the old location, and the new location. And that's it. We just move them at this point. So maybe update is a little bit too complex to... I'm not exactly sure the best way to test this right now. But move entity we can definitely test. All right, so Gravity, you're upset. Expected a reference. Okay, so then you are a reference to a vector 2. Collidable others. We need to get those two. So collidable others equals. So this is going to be self dot entities dot. I think we can just iterate through the values. Can I filter? Do the collidable others have to be cloned? Oh, I don't remember. They might have to be cloned. Okay, so if I do that, we have our entity. I want to filter if entity dot collidable is true, and if that is, give me there, and then dot collect you in. And there we go. The value of type standard vec entity. Right. Okay. And that's because, so this is a vec of entity, because collidable others is a vec of entity. Now let's say I have just another thing in here. What type are you? Or you're an unknown type. Can I set your type and you will yell at me? So a vector of a reference to entity. I mean, maybe. What if I comment you out? I comment you out. I want to get rid of all of the errors so that I can find out whether or not. Okay, are you? Okay, so 112. We borrow mutably. Then 114. We borrow again. Okay, yeah. Right, because we're going through all of these. Well, yeah, okay. And that's a big part of this is collidable others can't just be everything. We want to do a query and get all of the entities nearby the entity that we're updating. So what is that gonna look like? gonna be slightly different than this. Okay, so we can't quite do that. We probably do want to clone, but we need to clone. We need to do a query first, and then we can clone based upon the results of the query. Okay. So we need writable others is equal to self.query. Our query is a rect new. Now, how we tell what collidable others are and like what that really means, I'm not exactly sure right now. We're gonna have to like come up with some like, okay, we have our location. Now we know that the entity's location is based upon the center. Oh, and we have our standard unit width and height. So if I go by a full unit unit width, and these are F32s. So if I go by a full unit width in each direction, that might work. Where am I? What am I doing? Over here. So for our X, let's do our entity.location.x minus one full unit width to the left. So self.unit width. Now I'm not sure this is gonna work. Like we might have to store unit width because getting self out here might trick the trip the borrow checker. Okay, so then our y is entity.location.y minus self.entity dot unit height. Then we have our height. So and this should be, we want one backwards. So if we're going one full one, I want 1, 2. So 2 unit. So then for width, we want self.unit width times 2. Self.unit height times 2. Not. Yeah, okay, so 112 we borrow as mutable, and then 114 we borrow, I believe, right here. Yeah, second borrow occurs right here due to self with a self.query. So how do we want to take care of that? I mean, I could clone the grid. It would be a light clone, which wouldn't be the worst thing in the world. But it would also be everything being cloned. Just not the best in the world. Yeah, How do I want to deal with this? I think when we did this in the last time when we did our infinite runner, I cloned the entire grid. Because I wasn't exactly sure how to get everything without running into this problem that we're running into right here. So what do I do? I don't think switching to just a for loop would work here, but I mean, maybe it would. We could just do a standard for loop. We can do for entity in do that. Cannot borrow. Okay, yeah. So self. You're not yelling at us. Okay, mutable borrow occurs here, and then later occurs here. Cannot borrow self is immutable because also borrowed is immutable. Right. Now I wonder if I can get around this by basically. Well, okay. So this is looping through to actually run the update function. When I run the update function, I want the collidable others. So I want to get the nearby. I mean, I could store the grid in multiple pieces. In multiple structs, as it were. So we have basically our grid, and then we have, like, over here we have the entities struct that just stores the structure, and then we have the cells. So I guess we have the grid. Okay, so we have the grid and the entities. That could work out. Maybe ref cell cells. So I can get like, it can do some ref counting behind the scenes, and we can we could then do multiple mutable queries out of it. Maybe. So in here, in our cells, which one is yelling at this? It's because it's self. So even if it's self, it's still going to be a problem here. I think maybe like breaking these out into separate literal areas where we're grabbing it from might work. Also, hello, Silent Z. So if we have the entities is in the world, and then it's essentially passed, then the update would happen back in the other world, the other area. Yeah, I think that makes sense again. Yeah. Then allows us to come back here in world. We have this grid option grid, and that's fine. Although I probably want to probably don't need it to be an option. We then would have entities here, which would be a hash map of U32 and entity. When I create a new case, then when I create a default, I have entities, which is a hash map, new, and just let that be empty. Then what's going to happen here? when I do an insert, I insert into the grid. Okay, so the world inserts into the grid. So if we look up from the top here, we have new. Okay, set gravity. These are all fine. Set the size of the world. Set the unit size. Build loads the level. Add entity. Okay, so we take in an entity. If we have a grid, then insert the entity into the grid. And then at the same time, as soon as we insert into the grid, we also want to insert into entities. Okay, so then we can do. Now, are we going to run into the same problem here? Entities dot insert. Our key is going to be entity.id entity. In this case, we could make insert be a reference to insert because we don't need to actually. It's not going to be inserted then. Okay, so if we go to grid, insert, you're going to take a reference to an entity. We're going to remove wrong. Oh, we have the wrong grid. Okay. I basically want you to not do anything. We can just not have any of you. Where are you running? Where are you yelling about me now? I forgot the keyword. Let's unfold. Unfold all is Control K, Control J. Move entity. So I kind of just want to like this is the old grid. We want to like bring in grid v2. And maybe that would just be best to like just make the move over to it. Maybe let's just do that. Let's not mod grid anymore. Let's just do grid v2. We're gonna use grid v2 grid. Okay, so add entity. Now we're in grid v2. Okay, so insert. You take a reference to an entity. We get the coordinates. Don't need you. Then, okay, so for cell, we get new coordinates. Right. Okay. So we get the cell, and then we push the entity ID in, and then we don't do this. We don't even have an entities in here. We just don't store that. Which of course makes this just a little bit upset. Just a teeny tiny bit upset. All right, so we don't create hash map new for entities. In query. So in query, all we're doing here is get the IDs of the entities that we want match the query. So get the IDs of the entities that are within the query rectangle. So I don't actually need to do found entities anymore. In fact, this is going to be a vector of U32s. So found entities doesn't exist. We have the start and end. Okay, we have the indexes. Okay, we push our index in. I guess, okay, we still need found IDs. And you need to be mutable. So then, okay, we loop through all these indexes. If we have a cell, okay, so if we have a cell, get the vector for that, iterate through the cell, we're gonna get all the IDs, and then we don't need to like grab it out of here. It's just gonna be a simple found IDs. We can actually do this all in one go here. This will be found IDs dot push ID, like that. And then we return found IDs. Oh, you are a reference to U32. I mean, there's not really a problem with that. I can, sure, let's just do a reference to U32. You know, I can never remember, I remember reading in the Rust documentation that cloning or like getting a reference to a number like this, like a U, the U32 is actually more expensive than just cloning it. But I don't remember if I don't know if that's actually true or if that's just something like my memory being wrong. That being said, I do need just references for, well, it will be a double reference. I don't know if it matters. I know that U32s implement copy automatically, but I don't know. It probably doesn't matter. Okay, so get all entities mute. So suddenly, these functions make no sense anymore because get all entities mute, we don't need to do that. Get all cloned, we don't need to do that. It will get tied to lifetime of self. And because the grid is staying alive, because it's inside of the world, we don't need to worry about it. So the reference is going to exist. It's going to be fine no matter what. Move entity. Okay, so this one makes sense now. We need for move entity. So we have query. That's fine. Move entity. Update is not going to happen here. Move entity will. And get coordinates. Okay, that's probably helpful. Yeah, we're definitely using that. So I'm gonna save. What else do we have here? Then I think we're in our tests now. So when we insert, it's now a reference to this entity. And we no longer need that second assert. So insert, so grid.insert. Why are you only upset here? There you go. So insert those two entities. visible entities. So we query from the grid. And we can't actually get that second assert doesn't work for us either. Mismatch types. Okay, so vec, right? Because now you're going to be IDs. So a vec of a U32. There we go. Visible entities. We can test to see how many we got. We got 1. We could also test to see that we got the correct one. So we could do assert equal visible entities of position 0 should be the ID to get. So, okay. Can't compare. Sure, your reference. Okay, so test, get all mutable entities from the grid. We don't need to do that test. Get all cloned entities from the grid. We don't need to do that either. Moving entities between cells in the grid. Okay, so this is obviously going to be a problem here. We want to insert our entity in. We don't need to get all the entities out. So it's going to be interesting. We need to think about how this is going to work. We've inserted our entity into the grid. It doesn't know the feeling of deleting code. I know it is nice when we delete code, and it's the right thing to delete the code. So if I insert this entity, I need to I need to update. So grid dot update entity, like entity location. We're going to pass in the entity. Okay, the entity ID. So entity.id. We need the old location and the new location. So we've inserted this here. Let's do that old location equals entity.location. We're gonna mutate it now. So entity.location. So that means you need to be mutable here. .x equals, you should be 2.5 now. And that new location equals entity.location. They implement copy, so that should work for us. Then we want to pass in the old location and the new location. The new location. So not that. Okay, so you're upset because you don't exist yet. That's fine. Then now what do we assert? We assert now that it's gonna be, this one entity is gonna be in the correct cell. So we have to grab that out. So let coordinate is equal to, I wonder if I can do this x and y equal to self dot grid dot get coordinates. Okay, so this is going to be the new location. So new location dot x location dot y. Can't update take only entity and old location? Yeah, it probably could. It probably could. Probably could take a reference to entity and the previous location. I mean, I could even store the previous location in the entity, like as part of its state. I mean, that might be interesting. Then I can just get away with passing in just a reference to the entity. Okay, so let's get coordinates of new locations. This is really going to be entity.location.x, entity.location.y. That's going to give me the grid points here. We would then trust that okay, so then we're going to assert equal at grid.cells.get. Okay, so we're going to hand it the key. Oh, well, okay, so this is coordinates. There's going to be a reference to coordinates. Okay, so get that, unwrap it, then get the length. We expect this to be 1. And that's it. That's all we have to test here. Now I could manually calculate this too. And that might work. So update entity location. So instead of move entity, okay, so we're gonna have, you know what that means? We don't need the entity ID either. All we need is the old location, and I think that's what you were mentioning. That means we only have to pass in 2 things. So old location and a reference to the entity. To Dexon, hello. Okay, so let's add this in here. So update entity location. We have old location, which is a vector 2 32. Hello, Chantilly. And an entity, which is a reference to an entity. So we need to get the coordinates here. So let old coordinates equals self dot get coordinates. Pass in location. Arctic Space Fox, hello. Oh, you redeemed get the streamer game. Yeah, let's do it. Let me finish this one right here, and then we'll start the game up. Okay, so old location dot x old location dot y. Okay, there we go. Got that running. Let's. I don't need that. Okay, let's go. Let's play that game. All right, so we're gonna do cargo run, release. There we go. I was like, that took a little bit longer than normal to start up. That's fun. All right, let's do this. I need to put on headphones so I can actually hear the drops. Helps me avoid as many of these as I can. Oh, I can't believe oh, this is gonna be a fun one. I was gonna say, how did I not get hit so far? But, oh no. I saw the heart coming down, but oh, that was fast. Chantilly Cake with 18 points. Oh, and Arctic Space Fox. I think you have the new high completely. Again, please? Sure, let's do it. Let's do it again. One more time. I wonder if it would become easier for me if I implemented the ability to jump at different levels. So like right now I press jump, I jump at the same height every time. What if I like press less on here? Then maybe that will help out? Give me the heart. And not spend it right away. Too much fire. Ah. I was looking at the heart going like, it's gonna save me. But no, it didn't. Chantilly with the 51 points that time. Great job. Great job, everyone. Thank you for playing that. It's a lot of fun when we get like everyone in chat participating. So thank you so much, everybody. And also thank you, Arctic Space Fox, for requesting that. You're trying to send hearts to make the game last longer. But like the nice thing is, if you send hearts, you get the same number of points if you hit it. However, it is kind of up to me whether or not I can get to them or not. And they can also be used as a trap. Send out a bunch of snakes and fire, and I'll like, okay, I'm gonna go for it, and then I die. All right. What were we doing? Okay, so we're updating the entity location. So we have the old coordinates. Then we want to get the new coordinates. Oh, you need to start your game dev after finishing Zilby. I can't remember. Did I ask you what your game is going to be about? Let's see. Entity.location.x. Location.y. No, you didn't? Yeah, what's it going to be about? What type of game is it going to be? Okay, so then we want to check to see if these are the same. We're not going to do anything. So if they're different, that's when we do something. So if old coordinates is